This is Mr. Brooks, and welcome to Lesson 11.4, Volumes of Prisms and Cylinders. In this lesson, we're going to find the volume of a prism and the volume of a cylinder. Beginning with the definition of volume, which is basically the space that a figure occupies. It can be in cubic feet, cubic inches, cubic centimeters, whatever, just cubic units. The volume of a cube would be V equals E cubed. You're going to multiply length times width times height to get the volume of the cube. And since the length, width, and height are all the same, that is going to be E cubed. Cavalieri's principle states that if two figures have the same height and the same cross-sectional area at every level, then they're going to have the same volume. As you can see, these two stacks of paper will occupy the same amount of space, meaning they're going to have the same volume. So a right prism and an oblique prism are still going to have the same volume. Just multiply the area of the base times the height, which is stated here in Theorem 11-6. Volume of a prism is going to equal area of the base times the height. So, if we're trying to find the volume of the rectangular prism in example 1, again, we're just going to use volume equals area of the base times the height. Volume is going to equal area of the base is 20 times 24 times the height, which is 10. So the volume of this prism is going to be 4,800 cubic units. In this case, cubic centimeters. All right, quick check number 1 says, suppose the prism in example 1 was turned so that the base is 10 by 20 and the height is 24. Explain why the volume does not change. Please pause the video while you try to figure this out. Okay, again, volume is going to equal area of the base times the height. So this time it's going to be 20 times 10 times 24. So it's going to be 200 times 24, which is again 4,800 cubic units or cubic centimeters. Same area. Example number 2 says, find the area of the triangular prism. Again, the base of a triangular prism is going to be the triangles. The lateral faces are the rectangles. So please pause the video while you try to get this volume. Again, volume is going to equal area of the base times the height. So we're going to have to find the area of the base. Well, the base is an 8 by 8 by 8 equilateral triangle. So as we can see, the shorter leg is going to be on this 30, 60, 90. It was a 60, 60, 60, which we've now made into a 30, 60, 90. The shorter leg is going to be 4, so the height is 4 times the square root of 3. So the area of the base is going to be area of a triangle, which is 1/2 base, which is 8, times the height, which is 4 times the square root of 3. That's the height of the triangle, times the height of the prism, which is 10. It's the height of the prism. So what do we got? 16 times the square root of 3 times 10, or 160 times the square root of 3. And it gives it to the nearest whole number, so we punch that into our calculator, and you're going to get approximately 277 cubic inches. Okay, quick check number 2 says find the angle of this triangular prism. Please pause the video while you try to figure this out. Quick check number 3 says, find the volume of the oblique cylinder at the right in terms of pi and to the nearest tenth. Please pause the video while you try to figure this out. Okay, as we said a few times, volume of a prism or cylinder is area of the base times the height, even if it is oblique. Well, for a cylinder, area of the base is going to be pi r squared because the cylinder is a circle. So the area of the base is going to equal pi times 4 squared. They gave us the diameter 8, so the radius is 4. So the area of the base is going to be 16 pi times the height, which is also 16. So the area of this in terms of pi is going to be 256 pi cubic units, which in this case is cubic meters. And then you're going to punch that into your calculator, into the nearest tenth, and you will get, for part B, approximately 804.2 cubic meters. This concludes lesson 11.4.